So hello everyone, today we're going to be learning confidence intervals. So what is confidence intervals? Well, it is a probability that a parameter will fall between a set of values. So let me get my highlighters out here. And so the confidence intervals measures the degree of uncertainty or certainty in a sampling method. So normally we would use 90, 95, or 99%. So in the example right here on the bottom, you can see that we are using a 90% confidence interval. So what is the point of all of this? Well, the point of confidence intervals is to provide a more accurate estimate of the true population parameter and to convey the level of uncertainty. So let me highlight that, convey the level of uncertainty associated with the estimate. They're an important tool for making informed decisions and drawing conclusions from statistical data. So what are we going to be learning in this chapter? Well, we're going to be learning Z-based confidence intervals for a population when we are giving O, which is the standard deviation, the T-based confidence intervals for a population mean when O, or the standard deviation, is unknown. And then we're going to be going into the sample size determination, confidence intervals for a population proportion, confidence intervals for parameters of finite population. So explaining the diagram in the bottom here, or the example I should say, we are using 90% confidence interval. So what we could see here with the 5% is the level of uncertainty. So that would mean that if anything lands in this area under the curve, these areas on the curve, we would consider those by chance or a mistake, and that is something that we want to avoid. So I'm going to explain it later on in the chapter, but just for a brief summary of what you will learn. So yeah. Alright, so we're going to be explaining confidence interval for a population mean when our standard deviation is known. So first we're going to look at the formula for confidence intervals, which is the sample mean plus Z alpha divided by 2 times standard deviation divided by the square root of n. All of this part is what we consider the margin of error. So you can see right under, margin of error is literally the same formula as above except with the sample mean. So in reality, our confidence interval is just the sample mean plus the margin of error. So looking now, the significance level of alpha. Alpha is the probability of the event occurring by chance. So in our example above, and here I'll use this example, it's the probability of the red. And so our formula is 1 minus the confidence level. So if your alpha is 0.05, your confidence level is 95%. However, your alpha will be equally distributed into both tails left and right for 0.025. So using our alpha or finding our alpha can help us find our confidence level, and we could say the exact same thing. So let me just say this before. The z-score of 0.025 on the left tail is negative 1.96, and the right tail is 1.96 because it is a normal distribution and is identically symmetrical. So like I was saying before, if you find your confidence level, which is the probability that the value of a parameter falls within a specific range, so that's what it is. The formula is 1 minus alpha. So confidence level and your alpha, which is the probability of the event occurring by chance, correlate to each other. So you can either find, if you find one, you can help find the other one. So I hope that explains it. Alright guys, welcome back. Today we're going to be explaining confidence intervals for a population mean when our standard deviation is unknown. So when it is unknown, we must use the t-distribution. So this is the confidence interval formula. It's basically the same one as the z-score one from above, but we're going to be using the t-distribution. So x bar plus or minus t with alpha divided by 2 times s divided by the square root of n. So s is the standard deviation, or sample standard deviation. So just like the other one, The margin of error formula is just the second part of our confidence interval formula. So it's just right here. Let me highlight it for you guys. Draw with touch. So right here is our margin of error formula. And so yeah. So degrees of freedom. So here we're gonna have degrees of freedom, and this gives the spread of our t-distribution. So we can find degrees of freedom by doing n, which is our sample, minus 1. So and then now I'm going to explain how to use a t-distribution table. So for example, if we have a sample of 15 and our confidence level is 95%, well, then we would have to find our alpha. So we would do 1 minus 0.95, which is equal to 0.05. This is from the steps from before that I explained. So from this, we find our alpha, which is 0.05, but we must split it into both tails, so left and right. So the right tail would be 0.025, and when we're using the t-distribution table, we must always use the right-tailed. So in our distribution, we must look at t 0.25, so we find it here, and our degrees of freedom, which is just n minus 1. So 15 minus 1 is 14. So we highlight 14, we highlight our right-tailed alpha, and then we find where they connect, which is 2.145, and that's going to be the proportion of the right-tailed, or whatever sample it would be. So rules of a t-distribution: if n increases, our degrees of freedom increases. So remember that. Degrees of freedom increases, the spread of t decreases. So you want that to happen. So it's pretty much going back to the central limit theorem, but it's not exactly that, but it's implying the same thing. So the more you have of the more sample, the higher your sample is, the more spread t, the less spread t is going to be. So, and if degrees of freedom increases, your t curve approaches a normal curve. So like in the central limit theorem, if your n is higher than 30, in this case degrees of freedom would be higher than 29, your t curve is similar to a normal curve. So that's all we have to know when our standard deviation is unknown. Alright guys, so today we're going to be explaining the confidence intervals for a population proportion. So confidence interval formula for our population, it's with p plus z alpha divided by 2 times, this is going to be our margin of error formula, and you could just see here. Instead, let me highlight it over here. So this formula helps with upper and lower limits of our population proportion. So once you've gathered all the information needed, you would end up putting it into this formula to give out your final answer to your upper and lower limits for your population proportion. So what is the P with the hat? Well, it is a point estimate. So let me highlight there. And it is a single value estimate of a population parameter. So the point estimate formula follows x divided by n, where x is the number of successes. So the margin of error formula is exactly like our confidence interval formula for P, but it is just this. So this is going to help with the margin of error. And then going with the standard error, it's the standard deviation of our P hat. And it is just this part of the formula. So once you've gathered standard error and all of this, you could find your upper and lower limits to your confidence levels and use all of our knowns to gather your confidence intervals for a population proportion.